Hello friends, a warm welcome to yet another interesting session on instrumentation and control in power plant industries. In our previous session, we have learned about various types of instruments used in a power plant for measuring process parameters like flow, pressure and temperature. Friends, till now we already know the instruments and we are also aware of the pipeline or the equipment where it has to be connected to measure the required process parameter. But still, I'm not very sure how to install the instrument on process line to get the correct reading. So in this session, let's learn with me about the instrument installation diagrams, or also known as instrument hookup diagrams. Friends, if we go by definition, an instrument hookup diagram is a detailed schematic that shows how an instrument is connected to the process and to the control system. It includes mechanical, electrical, and pneumatic connections like impulse line, tubing, cable glands, junction boxes, and so on. Basically, think of it as a bridge between your P&ID and the actual installation at site. It tells the technician how to physically install the instrument, what type of tubing to use, what kind of fittings, where to connect the grounding wires, and much more. Basically, there are three types of instrument hookup diagrams. First type is process instrument hookup diagram. It tells us how the instrument is connected to the process parameter, or in other word, how the process medium is transferred to the instrument, most of the cases directly or sometimes indirectly also. Next type is pneumatic hookup diagram. As the name suggests, it is for airline, mainly for solenoid valves and pneumatic control valves. And the third type is electrical hookup diagram. This is rarely used and is prepared only if required as per customer contract. This is for electrical wiring, cable glands, junction boxes, etc. So in this session, we are going to focus on process instrument hookup diagram. Why it is important? Without a hookup diagram, even if you select the right instrument, installation could go wrong. You can end up with wrong impulse line length, wrong material, wrong slope of tubing, or even unsafe installation, leading to wrong readings or even system failure. Hookup diagrams ensure standardization, safety, and smooth commissioning of your instrumentation system. For example, a wrong slope, basically insufficient downward slope of impulse line in water application can cause entrapped air bubbles, which could lead to wrong reading. Or in case of high pressure line, a threaded connection instead of socket weld can cause leakage, leading to again incorrect readings. So before moving with explaining the instrument hookup diagram, explaining each and every component, let's first check what all information we are going to get from these diagrams. On this top right side here, we can see a table listing all the instruments in the plant for which the same typically is applicable. Means all these listed instruments should be installed in the field as per this particular installation diagram. Next, on the bottom left side, we can see this table listing all the material used for installing one instrument. In this instrument hookup diagram, each hardware used is assigned an item number, and the same is used in this table. This table provides for installing each instrument what are the different type of hardwares are used, which material this hardware is made up of, and what size these hardware are required, and in how much quantity these are required per instrument installation. This table listing all hardware required is called bill of material. This table is very important and very helpful for listing and purchasing the hardware required for instrument installation by multiplying per instrument quantity with the number of instruments this hookup diagram is applicable for. For example, in this particular case, we have six instruments for which this instrument hookup diagram is applicable. So if we multiply this quantity mentioned with the 6, then we will get how much quantity we have to purchase for installing all the DP type differential pressure type pressure transmitters. Next, we have a main instrument hookup diagram. So this diagram shows the complete details from the process pipeline up to the transmitter. All hardware used in the path are assigned with item number, the details of which are listed in the bill of material table below, which we have already discussed. And last but not the least, there is a mention of special notes on the sheet. Like in this particular diagram, special note is regarding the supply of scope of a five-way valve manifold used for DP transmitter installation. Let's move for let's walk through a simple example, a hookup diagram for differential pressure transmitter used for water services. From the main process line, the mechanical team takes the tappings, in most of the cases welded connection, and on the other side of this pipe is primary isolation walls are installed. The primary isolation wall looks like this, shown in the picture. The primary isolation wall has the provision to connect 1-inch pipe weld connector. Up to this primary isolation wall is the scope of mechanical team, and our basically INC job starts after this. So first, to fit into the above mentioned primary isolation wall socket, we need a process connector. A process connection could be flanged, threaded, or socket weld. In this example, as the pressure is high, so socket weld is preferred over the threaded connection to avoid the leakages. Thus, the above primary isolation valve is also purchased with the compatible provision. If we look at the bill of material corresponding to this item number 2A.4, we get to know that we require two numbers of pipe weld connectors of material SS316. The size used in this case is 1-inch diameter pipe socket weld on the valve side, and on the other side it is suitable for half-inch outer diameter compression tube fitting. Outer diameter basically written as OD. The pipe weld connector on 1-inch side is inserted into the socket on the primary isolation wall, and a fillet weld is made around the joint to make the connection permanent leak proof. Next, to transmit process pressure or temperature from the process to the instrument, we use impulse tubes. The impulse tubes are basically hollow tubes. The material used is ASTM 8213 TP316. It is a type of authentic stainless steel, basically seamless tubing used for high temperature and high pressure. Minimum thickness used is 0.065 inches. As the other side of the pipe weld connector is compatible for half-inch compression tubing, thus the impulse tube of half-inch OD, means outer diameter, are used. Here, if we notice, a slope is shown downwards towards the transmitter. The slope in the instrument hookup diagram ensures that the impulse lines are properly drained or vented, preventing inaccuracies and ensuring the reliable operation of the instrument. The slope is generally 7.5% or more. The direction of slope is also important and is dependent on the fluid which we are measuring. For example, if we are measuring gas, then for gas services, the tubing connections for connecting these tubes, the process line to the measuring instrument should slope upward from the tapping point. This allows any accumulated fluid like condensate to drain back into the process line, preventing them from trapping in the impulse line and affecting the instrument's accuracy. Whereas for liquid applications, the tubing should have a downward slope of basically downward slopes toward the instrument to ensure any entrapped gases or vapors can rise and vent, preventing bubbles from interfering with the measurement. For steam applications, similar to the gas applications, the instrument tubing should be sloped upward from the process connection to the transmitter. This allows condensate to drain back into the process and preventing it from affecting pressure readings. Next is basically impulse tubes come in standard length. Thus, to extend the length means to join the impulse tubes, we need tube unions, and which are made up of uh, same material SS316 and is of the same size, basically same compatible size of half-inch OD, so that half-inch OD impulse tube can fit into this tube unions. Next in line are root walls. Basically, these root walls are globe walls. The main purpose is to isolate the instrument from the main process line for draining and flushing the instrument for basically instrument maintenance purpose. Next is equality. Uh, Here, if we see, basically we have two different paths, one going to the instrument and second for flushing during the maintenance and calibration. Thus an equal T is installed. Material is same SS316 and the size is suitable for half-inch OD compression impulse tubing. For the connection of the impulse tube to the five-way wall manifold, we need a male connector. So one side of this male connector is suitable for half-inch OD impulse tube and the other side is half-inch NPT male connection as mentioned in the bill of material, and same is also shown in this photograph. Next important hardware is five-way wall manifold. Material used is SS316. The two impulse tubes via the male connector are connected to the high pressure and low pressure port of the five-way wall manifold, which is connected to the HP basically high pressure, and LP low pressure legs of the differential pressure transmitter. And one port which is shown in red is for equalizing, and the rest two ports are for venting high and low pressure side. On the below side, there are two lines with root walls installed. Again, root walls are globe walls. These are used for flushing and draining during maintenance and this calibration. So this was all about instrument hookup diagram for DP transmitter. Friends, till now we have, if I am successful to make you understand each and every detail of the DP transmitter installation diagram, then I am sure you can easily understand rest all instrument hookup diagrams yourself. Like this DP type flow transmitter, level transmitter in case of your tank or drum, in case your flow transmitter for steam services, pressure gauge, flue gas application, then pressure transmitter in water services. This you can easily understand on the similar basis as we have already explained about DP transmitter. However, in some steam cases, you may find condensate port also, so that basically the purpose of condensate is to uh, help so that a condensate will not interfere with the instrument reading. Otherwise, the rest all installation is pretty similar. Now, before concluding our today's session, let's discuss two most important questions that may arise during preparation of instrument hookup diagram. So our first question is when to use three-way valve manifold and where five-way valve manifold is required, and what are the differences. Basically, a three-way valve manifold is used for differential pressure transmitter measuring flow, level, or differential pressure. Ports has a high pressure isolation valve, which is to isolate high pressure side. Then Next port is for low pressure isolation valve, which is to isolate low pressure side, and one equalizing valve, connecting high and low side together for zeroing or calibration. It allows you to basically isolate the transmitter from the process pressure, and second purpose it solves is equalize pressure on both sides before removing the transmitter. A three-way valve manifold is common in permanent installation where venting and draining is not required. However, if we talk about five-way valve manifold, if five-way valve manifold is used for differential pressure transmitters where frequent calibration or venting is required. So as the name suggests, it has five ports. One port is for a high pressure isolation valve. Second is a low pressure isolation valve. Third is equalizing valve. These three are similar to three-way valve manifold. In addition to these three ports, we have also high side vent or drain valve and low side vent or drain valve. So why use basically the use is clear that in addition to isolation and equalization, you can prevent trapped air. Trapped air is basically in case of liquid services, or drain liquid in case of gas services. It allows zeroing calibration without removing the transmitter, and it makes easier to troubleshoot or check for plugging. Basically, rule of thumb is DP transmitter for basic service with infrequent maintenance. You can use three-way valve manifold, and if it is a DP transmitter for frequent calibration with venting draining need, you have to use five-way valve manifold. There could be cases you need for local gauges or for absolute pressure transmitter, you can use two-way valve manifold, which provides only isolation. Next is we can basically next question in mind could be where to use threaded connection and where to use socket weld connection. So friends, both threaded and socket weld connections are common for small bore piping, generally less than 2-inch NB in instrument and process piping work, but their selection depends mainly on process pressure rating, leakage tightness, and ease of maintenance, and also dependent on vibration. So threaded connections are used where we have low to moderate pressure services, generally up to ASME class 600 and sometimes up to 900 for special cases. And it is used only in non-hazardous fluids or gases where small leakage risk is acceptable. And it is used in low vibration areas. And if it is a temporary or frequent removed instruments like pressure gauge, temperature gauge, pressure switches, we can go with threaded connection. Typically used in small bore drains, vents, and test connections with medium like compressed air, water, nitrogen. Typical example of threaded connection is pressure gauge on the utility water, drainage wall for impulse line, flushing and to purging connection, etc. The advantage is basically it is easy to install and remove without welding. Second is no special tool needed, just pipe wrenches and sealant or tape. And third one is good for quick field modifications. And limitations, as we already discussed, first threads can be leak point over time. Second is not suitable for corrosive, high temperature or hazardous fluids. Threads are stress concentration concentrators, and if we install it in vibration prone area, then it can loosen under vibration. Whereas if we talk about socket weld connection, it is used for high pressure services, often ASME class 800 and above. It is suitable for hazardous and flammable fluids like hydrocarbon, toxic gases, where a leakage is totally unacceptable. If it is vibration prone areas like near pumps, compressors, or turbines, we have to go with socket weld. In high temperature applications like steam lines, hot oils, socket weld is preferred. And if it is a permanent instrument installation like DP transmitters, flow element, impulse line in critical services, it is good to always use socket weld connection. So typical example of socket weld connection is impulse line for steam services, high pressure hydrocarbon lines to transmitters, root walls on refinery process lines. Advantages it is of socket this socket weld connection are stronger and more leakage tight than threaded connection, better suited for vibration and fatigue resistance, and suitable for services with severe conditions. Limitations, definitely everything has certain limitation. So limitation of socket weld connection is it requires welding skills and proper inspection, and it is more difficult to replace or modify later. And socket weld have small cervix that can be a corrosion spot if not properly cleaned. So this is a small table which will help us to better choose between socket weld and threaded connection depending on the application. So if it is a pressure gauge, pressure switch or root valve for a differential pressure or pressure transmitter in utility services, then we can go with threaded. But if it is for critical or high pressure, then definitely we have to choose socket weld. And if it is a temperature gauge or thermo well for low pressure line, then threaded. But a temperature gauge or thermo well in high pressure line, we have to use socket weld. Similarly, this manifold walls, impulse lines, basically SS tubings in low pressure, we can use threaded, and if it is high pressure, we have to use socket weld. Drains and vents for utility, which are not much critical, we can go with threaded. But if it is carrying hydrocarbon or steam, then socket weld is required. So basically, a quick rule of thumb is we have to ask ourselves the question, if it leaks, will it explode or poison someone? If the answer is dangerous, then go for socket weld. Otherwise, if harmless, then you can easily go with threaded. Second question could be in mind that if it is going to be removed often. If yes, then definitely to remove frequently, we have to use threaded. But if it is no, it is a permanent connection we need, then socket weld. Third is the service in which it is installed. If it is high pressure, high temperature, or vibration is high, then socket weld has to be used. But otherwise, we can go with threaded. And is it in a utility line like air, water, and nitrogen, which are known hazardous, then threaded is fine. So friends, that was all about instrument hookup diagram. I hope this session will serve you as a quick guide next time you come across deciding the safe and accurate installation of an instrument. We will meet again in our next session. Till then, stay safe, stay healthy, take care. Bye.